All right. So chapter 4, we're going to start with something known as a probability distribution. So a probability distribution is going to be like a T-chart. It's going to have an X and then a P of X. And of course, this P of X stands for probability of X, and the X is an event. So for example, if you're rolling a dice that's six-sided, you can get a 1, 2, 3, 4, 5, or 6. And there's a 1/6 probability for each of those outcomes. So this would be a probability distribution. Now, the key thing with the probability distribution is that each of the probabilities must be between 0 and 1, and then all of it must add up to be 1. So everything must add up to be 1. So X can be whatever the result is, but the probabilities must all add up to 1. So 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 is 1, and each probability is between 0 and 1. So likewise here, this might be some type of game where you either lose $5 or you win $10. There's a 5/6 chance of losing $5. This is 5/6. 1/6 chance of winning $10. This is 1/6. So these two numbers will add up to 1. So you have a probability distribution. So here's another example of one where you got some values of X, and each P of X here is listed, and each P of X is between 0 and 1, and it all adds up to 1. 0.3 plus 0.2 is 0.5, plus 0.2 is 0.7, plus 0.1 is 0.8, plus 0.2 is 0.10. So in a probability distribution, got a fly buzzing over me here. The key is that each P of X must be between 0 and 1. So each P of X is between 0 and 1. And then all of the P of X's must sum to 1. Those are the two requirements for a probability distribution. So let's take a look at a question here that it might ask you on Alex. Wish that fly would go away, but it's not. It keeps buzzing over my head. All right, so here we have a probability distribution. The value of X is listed and each P of X is listed. We have to put numbers in the blank that make this a probability distribution. So all of these numbers have to add up to 1. So all of those numbers have to add up to 1. So if I just use my Alex calculator, I'll do 1 minus 0.23, minus 0.26, and then minus 0.27. And we have 0.24 left. So we just have to make whatever numbers we put in the blanks have to add to 0.4. So if I want to do 0.12 and 0.12, that will work. And that all adds up to 1. So that's how you do that one. Let's take a look at these type of problems here. So in this case, it gives us a list of each outcome. And this is if we're rolling a fair die. And it's either going to be odd or even. This is a formula that we're using, but it actually gives us the results right here. So we don't even need to worry about that formula in this case. And it says, for what are the values of X? Well, what are the values of X that we see? I see a -2 and a -4. So it's going to either be -4 or -2. Then we have to list the probability of equaling -4. Well, we got 1, 2. So that's 2 out of 8, which reduces to a fourth. And then -2 is 1, 2, 3, 4, 5, 6. 6 out of 8. So we just count the number of times that value appears, and then we can check it, and it should be correct. Yep, we're good to go. Try another one here. So same thing, I see -5 and -3. So we'll do -5 and -3. -5, I see 1, 2, 3, 4, 5, 6. So 6 out of 8. And then -3, I see 1, 2, see 2 out of 8. And that should work. And we're good to go. So that's, again, a probability distribution because it all adds up to 1. All right, and then we'll take a look at cumulative probabilities here. So here we have a value of X, and we have each probability. So less than or equal to 2. So that would be this one. We need to calculate the probability. So we do 0.27 plus 0.19. Which is 0.46. And then higher than 3 would be these guys, 4, 5, and 6. So we got 0.15, plus 0.13 plus 0.10, 0.38. So you just need to read that very carefully to get those correct. All right, so that is your introduction to probability distributions. And let me know if you have any questions. I'm available through email, but that should help you out with that. So I hope you guys all have a great day. We'll see everybody on Wednesday.